How wind farms work. Wind farms look deceptively simple from a distance. Large white turbines spinning slowly across hills, coastlines, or offshore waters. But behind those rotating blades is a massive coordinated energy system involving aerodynamics, power electronics, grid infrastructure, weather forecasting, and surprisingly complicated maintenance logistics. Which means every turbine is basically functioning as a giant rotating electricity generator connected into a much larger power network. So today we are going to walk through how wind farms actually work and how moving air becomes electrical power for entire cities. Wind farms generate electricity using wind turbines. Moving air turns large blades connected to generators. Electrical energy then flows into the power grid. Wind is moving air. Moving air contains kinetic energy. Wind turbines capture part of that energy and convert it into rotational motion. Wind turbine blades work somewhat like airplane wings. Air moving over the blade creates lift forces. These forces cause the rotor to spin. Modern blades are carefully shaped for maximum efficiency. The spinning blades connect to a central hub. The hub drives a shaft inside the turbine. Rotational energy moves deeper into the turbine system. Many turbines use gearboxes. The gearbox increases rotational speed before reaching the generator. Some newer systems skip the gearbox entirely using direct drive generators instead. Because apparently maintaining enormous gear systems hundreds of feet above ground was eventually considered slightly inconvenient. Generators convert rotational motion into electricity. Magnets and coils interact inside the generator. Mechanical motion becomes electrical current through electromagnetic induction. Wind turbines are built extremely tall intentionally. Higher altitudes usually provide stronger and more stable winds. Tower height improves energy production significantly. Turbines cannot simply be placed randomly. Spacing matters heavily. Turbines create turbulent airflow behind them called wake effects. Proper positioning improves efficiency across the entire farm. Some wind farms operate offshore. Ocean winds are often stronger and more consistent. Offshore construction and maintenance become much more complex and expensive. Electricity generated inside the turbine must be conditioned before entering the grid. Power electronics stabilize voltage and frequency. Substations collect electricity from multiple turbines simultaneously. Modern wind farms rely heavily on automation. Sensors continuously monitor wind speed, vibration, temperature, and electrical output. Control systems adjust turbine blade angles automatically. Extremely high winds can damage turbines. Braking systems stop rotor movement during dangerous conditions. Blade pitch systems reduce stress during storms. Wind turbines require regular inspections and repairs. Gearboxes, blades, bearings, and electrical systems experience continuous stress. Maintenance crews often work at significant heights, which is a career path that quietly assumes people are comfortable repairing machinery while suspended above farmland. Wind conditions constantly change. Electricity generation varies throughout the day. Power grids balance wind energy using other generators, storage systems, and grid management tools. Wind energy produces electricity without direct fuel combustion. However, turbines still affect landscapes, wildlife, and local environments. Energy systems always involve trade-offs somewhere. Wind farms became major parts of modern renewable energy infrastructure. Large-scale turbine systems transformed how countries generate electricity. Modern power grids increasingly depend on renewable generation technologies. To wrap up, wind farms work by using aerodynamic turbine blades, rotating shafts, electrical generators, power electronics, and grid infrastructure to convert moving air into usable electricity. Turbine layouts, control systems, and monitoring networks help maximize energy production across large wind installations. Offshore and onshore wind farms became important parts of modern renewable energy systems worldwide. Modern wind energy combines mechanical engineering, electrical infrastructure, and atmospheric science into large-scale power generation systems. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.